Okay, in stamp homework, page 1, and I will stamp your score sheet. What I need you to get to is, let me find it, the 5th page, which is, this is the 5th page, but we want to look at the side that has the several triangles on it. So I need you to look at this page. All right, now this is going to require what we did yesterday, and I'm gonna show you 2 new special segments and their point of concurrency. Yesterday we looked at, and I'll show it up here. We looked at the circumcenter, and it's not loading. Why isn't it loading? Let's see if this one works. No. All right, here we go. So yesterday, circumcenter. Now, circumcenter is made with the perpendicular bisector. That's the special segment. Okay, the point of concurrency, the point where the perpendicular bisectors intersect, we call that the circumcenter. Now we saw yesterday, there's times when it's inside the triangle, when it was a right triangle, it was on the triangle, and when it was obtuse, it was outside. Do y'all remember that part? Okay, the other one we looked at was in-center, and I think it's this one. No, it's this one. Yeah, this is the in-center. Okay, the in-center was made with a different type of special segment. Does anyone remember what the angle bisector? The angle bisector. So on this animation, they're showing you that the angles are being bisected, and where all the bisectors intersect, that point of concurrency is the in-center. Okay, so that was those 2 yesterday. We remember those 2? Okay, so hopefully you gotta know what they look like. All right, the new one, if you looked at one of the videos I posted, the next 2 new ones we're gonna look at is a centroid. Coach, you might want to pay attention. Okay, the centroid is formed by medians. They're trying to show you medians up here. Medians only touch the midpoint. It goes from the midpoint of a side to the vertex. It goes through the midpoint. Okay, you're thinking of mid-segment, and that's another word for a median. Yeah, like the middle, yes, huh? Well, kind of, yeah, we're getting there, yes. Okay, so if it's only dealing with midpoints, and we have the point of concurrency for medians, that is called the centroid. We're going to learn a rule with that one. And then we have our last one that doesn't have a rule to it, which is the orthocenter, okay? The orthocenter is formed with the altitudes, okay? An altitude is only basically a perpendicular segment from the vertice to a side. Now, the orthocenter is like a circumcenter in the sense that it could be inside the triangle, it could at times be on the triangle, or it could end up being outside the triangle, depending on the type of triangle. Okay, now what you're going to be tested, or how you're going to be assessed, is if I give you the picture, like all the pictures are given to you here, can you identify the type of point of concurrency that they're showing you? Would it be a circumcenter? Would it be a in-center? Would it be a orthocenter? Would it be a centroid? That's what you're trying to determine right now. Where I'm giving you time to work it out, take a risk, make a guess if you need to, ask a group member, but we're checking this. I want to see, can you come up with some type of understanding based on the picture? Because the picture is going to be given to you. You're going to have to identify what is being shown. Do we have questions? All right, get started. All right, number 4 should be circumcenter, because it's a perpendicular bisector. 5, orthocenter, because it's only altitudes. They're only perpendicular. They do not bisect. Okay? 6. Repeat which one? Which one? We'll do one. 5 is the orthocenter because it's only perpendicular. They're not bisectors. So that means they're altitudes. Okay? All right, 6 is an in-center because they're all angle bisectors. This is showing you an angle bisector. That's an angle bisector. That's an angle bisector. 7 was an in-center as well because they're all angle bisectors. You might want to write Y if you're getting them wrong because you're okay. 8 circumcenter because they're all perpendicular bisectors. 9 is a centroid because they're showing you medians only. It's a midpoint going to the vertex. The segments that they're showing you are medians. So all you see are the tick marks on the outside, correct? So that's proving that this is a midpoint. That's a midpoint. Over here, midpoint, midpoint. So you're using medians. Only perpendicular. They're altitudes. An altitude is only perpendicular. All right. 10, in-center. 11, orthocenter. This segment here is an altitude because it's only perpendicular and it's perpendicular from the side to the vertex, to that vertex P, okay? And then if I do this side, I'll do a different color. This side would be perpendicular to that side, and that's why the right angle is right there. So actually these two sides here are altitudes to each other. They're both, this is an altitude, this is an altitude, and this is an altitude. And when they all meet is at P, where all three lines meet. That's why it's orthocenter. That only happens with altitudes. They're only perpendicular. They do not bisect the side necessarily. They can sometimes, but it's only perpendicular. All right, 12, centroid. 13, orthocenter. 14, centroid, and 15, circumcenter. Questions on any of these? Orthocenter. You only look at the perpendicular lines. Which line? But to be an altitude, it has to be, to be perpendicular, it has to go from a side to a vertex. Okay. It bisects the angle. So right here, because it's being bisected and it's bisected that angle, then I'm going to just add the arcs to show that those two parts are congruent halves. So because it's being bisected, we can find the value of x and the measure of angle RA by setting up an equation with that relationship. Yep, 7x equals 4x plus 27. So now we can solve for x. I want you to do that. Solve for x. What was it, Rahel? Yep. So you get x equals 9. Now, we have to find the measure of angle IRA. How'd you get that, Cussie? You're right.
RA is the right.
Mm-hmm. Yep, it's this. So we do 7 times 9. Yep, 63. So this whole part on this section is taking the key words, taking the key information, and using that information, its theorem, its definition, and applying it to problem solve. So in example 2, it says QE is a perpendicular bisector of MU. Find the value of M and the length of ME. So what's the key word or key information? Okay, so what does that mean is occurring if it's a perpendicular? ME and EU are the same because E is going to be the midpoint, and it's perpendicular, so that means we have to add the box as well. So what information can we now apply? Yeah. 6m minus 3 is equal to 7m minus 8. What is m going to equal? Yeah, m equals 5. All right, they want us to find the length of ME. Yeah. Yeah, find the length of ME. Yeah, 27. Are we okay there? Kind of understand taking the key information, using that to problem solve. Yeah, that would just be extra information, yes. And sometimes they do that. I'm glad you saw that. Okay. All right, I'm gonna come back to example 3. Let's look at, wait, let me make sure. Yeah, look at example 4 for me real quick. It says find X and EF if BD is the angle bisector. So we know we're working with an angle bisector. We don't have an example 4? Oh, that means your copies are back. Do you have, what do you go to next? Median? Okay. Right here? All right. All right, let's get down the definition for a median. And I'll give you that example tomorrow. All right, a median is a segment. Watch this. A median is a segment whose endpoints are a vertex of a triangle, and the midpoint of the side opposite the vertex. Okay? The vertex of a triangle and the midpoint of a side opposite the vertex. The centroid is your point of concurrency for the median. Okay? So I'm highlighting these 3 things because all of these go together. If I have a median, then all 3 medians form the centroid, and then the centroid has a theorem to go with it. Are we okay on that part? What I want you to do so we can get this, constructed correctly, trace your BAC triangle here, trace it on patty paper, and then we're just going to find midpoints. We're just going to find the midpoint of each side.